to solve another Leetcode problem. 1775 equals some arrays with minimum number of operations. And this is going to be a hard problem. So we are given two arrays of nums1 and nums2, and the value inside nums1 is just coming from 1 to 6, and similarly for nums2. But the length of nums1 is different from the length of nums2. So in one operation, we can change any integer's value in any of the arrays to any value between 1 to 6. So for example, we can change this 1 to 6 or this 6 to 1. It is okay. We can change this 2 in nums2 to 6 or to 1. That is okay. We can change as we like, but the value gonna be between 1 to 6. Yeah, but it is not necessary to change this value 5 to 5 because definitely you didn't change anything. So we're gonna return the minimum number of operations required to make the sum of values in nums1 equal to the sum of values in nums2. If we cannot do it, we're gonna return a -1. So let's try to understand the example 2 first. Yeah. So for this example 2, we should know how many ones. 1, 2, 3, 4, 5, 6, 7. So it's gonna have 7 ones. And for nums2, so the sum of nums2 is 6. So they are not equal. But how can we make them equal? So the answer is impossible. But how can we prove that the answer is impossible? I think we can check it easily. We can check the minimum sum of nums1. So what's going to be the minimum sum of nums1? We know that the actual sum of nums1 is 7. But we should also know the minimum sum of nums1 after change. So after change, that means we will not change anything because itself has already become the minimum. So it's going to be 7. So what could be the maximum sum of nums1? So if we change 1 to 6 for all of them, so it's going to be 6 times 7, so it's going to be 42. Yeah. So that means if we are giving an array nums1, according to the description, we can change 1 to 6, and we can change the 6 to 1. So the minimum value is going to be 7, and the maximum value is going to be 42. So what about nums2? So the actual value is 6, but what about the minimum value? So the minimum value for nums2, because the length of nums2 is 1, so we can change the 6 to 1, so it's going to be 1. Yeah. So the maximum value of nums2, I mean the maximum sum of nums2 is going to be 6, because we don't need to change it. Yeah. So as you can see that the minimum value in nums1 is even more than the maximum value in nums2, because 7 is more than 6, right? So this means no matter how can we change that, that is impossible. So that is one way. Yeah. Another way is similarly, maybe here in nums2, we have a value of maybe 43. Yeah. Maybe let me try to use a better example. Yeah. Maybe for nums2 we have a minimum value 48. Yeah, I don't know, just an example of 48. Maybe there are 48 numbers. Yeah. And the maximum value for nums2, maybe there are 48 times 6. Yeah. And because of the minimum sum in nums2 is even more than the maximum sum of nums1, 42. 48 is more than 42. Basically, it means it is impossible. So according to this, at least we can try to find the cases which is not impossible. We can try to find the return of -1 cases. I think this is going to be easy. Yeah, so let me first finish writing this one, because later on the problem is going to become a little bit harder than we expected. So I'm going to prepare n1 and n2. It's going to be the length of nums1 and the length of nums2. So we're going to check the minimum sum of nums1 and the maximum sum of nums1. So the minimum is going to be n1, because n1 times 1 it is n1, and the maximum is going to be n1 times 6. And let me just prepare for nums2. So the minimum sum of nums2 and maximum sum of the num2 is going to be n2, and n2 times 6. So from here we can have a check. So the minimum of nums1, if it is more than the maximum sum of nums2, or the minimum sum of nums2 is more than the maximum sum of nums 1. So we can return a -1 directly, and because we should know that that is impossible according to our example coming from here. There's no examples, but as the example before, for this example, for the second example, we should know that this is 7, this is 42, and for nums 2, this is 1, and this is 6, and this 6 is even less than 7. It means it's impossible because there's no overlap. We should know about that. Yeah. Now, if we've already checked the not possible cases, but if it is possible, it means there must be some number of changes we can make to make the sum of nums 1 equal to sum of nums 2 after we change some value inside nums 1 to some other value between 1 to 6, or some value inside nums 2 for some value between 1 to 6. We can change like the examples in example 1. So for example, we can we can change nums to 0 to 6. Yeah, it is okay. Nums to 0 to 6, it's gonna become this one, and we can change the nums 1 5 to 1, and nums 1 2 to 2. Yeah, so finally we're gonna have this kind of array 6 1 2 2 2. Yeah, and 6 1 2 2 2 2. So the result gonna be 15, and for nums 1 the result is also 15. Yeah, because we only need to change the nums 2, as we can see from the examples. Here is 6, here is 1 and 2. Yeah, so the sum of them gonna be 15, and nums 1 itself, the sum of nums 1 gonna be 15. So it means there are 3 changes, but we don't know why 3 is the minimum. So this is the greedy idea. We always want to change as much as we like. So for example, there are numbers inside nums 1 and nums 2. And first of all, we want to check the difference of nums 1 and nums 2. So for example, in this example, the sum of nums 2 is 10, and the sum of nums 1 is 21. So first of all, we're going to check the difference of nums 1 and nums 2, because currently, if they are not equal, the nums 1 can become bigger, or the nums 2 can become bigger. Yeah, or they are equal. If they are equal, we are safe, we don't need to do anything. But if they are not equal, so the nums 1 can be bigger, or the nums 2 can be bigger. That's just amazing. We always want to let the nums 2 to be bigger. So we're going to change this one to nums 2, and this one to nums 1. Yeah, because we always want to fix the example. So if the nums 1, the sum of nums 1 is bigger, so we're going to change nums 1 and nums 2. We're going to shift it. Yeah. Now we are sure the nums 2 gonna be the sum of nums 2 gonna be bigger, and the sum of the nums 1 gonna be smaller, because this gonna be nums 1 and this gonna be nums 2. And we're gonna check the difference. So the difference is gonna be 21 minus 10, and it's gonna be 11. Yeah. But how should we know how many changes we can make the difference to be 0? Yeah, because currently the difference is 11, but actually we want it to be 0. Yeah, so this means for nums 1, for nums 2, we want to decrease the value as much as we can. Maybe we want to decrease the value to some values, maybe 15. Yeah, and for nums 1, we want to increase the value as much as we can. Maybe we want to increase the value of nums 1 to 15. Now they are equal, and we just need to check how many operations. Maybe it is 3. Yeah. So this is our greedy idea of solving the problem. First of all, we're going to check the difference. So the difference is 11. We want it to become 0. How can we let it become 0? So we want to increase the we want to decrease the values in nums 2 and increase the values in nums 1. But what is the maximum value we can decrease in nums 2? Definitely it is 1. So for example, for this value is 6. And if we want to decrease the value, so for 1, it is the minimum value we can decrease. So it means the difference is going to be 5. So for this 6, it means we can decrease a difference of 5. So for example, this value in nums1, it is 1. We want to increase it. So what is the maximum value we can increase? So we can increase from 1 to 6. So the difference is going to be 5. So we only consider the difference of values. So we're gonna need a counter to count the difference of values. So maybe we're gonna count the 5. So how many 5s we can count? Yeah. So so for this one, it can increase to 5 to 6, right? And this one can also increase to 5. So it means that it has 2 values which can increase from 1 to 6. And for here, we have 1 value. It can decrease to 6 to 1. So it means how many 5? So there are 3 of 5s. Yeah. But our difference is 11. So but the value with increase and decrease, it's going to be 15. It's going to be 3 times 5. It's going to be 15. Because this 15 is more than and equal to this 11. It means it is possible, right? Yeah. So if it is possible, we just need to count how many operations. Definitely the operation cannot be 3. But for this example, it is 3. But how it is calculated? Yeah, so maybe because inside the count, maybe it is 10. But definitely the operations cannot be 10 because 10 times 5 it is 15. Yeah. So for us, we only need to make it to 0. We don't need to make it more than 0, right? So how many operations? So why it is 3 operations? Because the difference is 11. So we're gonna use 11 and divided by the value 5, because this 5 is the maximum value we can increase and decrease at the moment. So we're gonna choose 5. Maybe 5 is not possible. We're gonna choose 4 and 3, 2 and 1. But firstly, according to the greedy idea, so we're gonna choose 5. So if we choose 5, so how many operations do we need? Yeah, because this 3 times 5, definitely it is 15. It is more than and equal to 11. It means it is possible. So we're gonna stop the check. But we need to count how many operations. So the operations are going to be 11 divided by 5 with a ceil operation. So in mathematics, we're going to use a ceil. So it's going to be 3 operations. It means for 1 operation, we can reduce 5. So 11 reduce 5, it's going to become 6. And we're going to do another operation. We're going to reduce 6 to 1. So the difference is going to be 1. But still, we need to do another operation. Even the maximum value we can do is 5, but we only need to decrease a value of 1, so it is okay. So there will be 3 operations. Yeah. So this is the final answer. Yeah. Now we're gonna use this kind of greedy idea to solve the problem. Yeah. So first of all, we're gonna check the difference of nums2 and nums1. Because I always want the nums2, sum of the nums2 to be bigger for simplicity of such problems. Yeah, because there are only 2 cases. The nums2 can become bigger, or the nums1, the sum of nums1 can become bigger. So the D is called the difference. It's going to be the sum of nums2 minus the sum of nums1. Now I want to check this difference value. So if this D is less than 0, I want to change the value of D, because I always want to let the difference to be more than 0. It means the sum of nums2 would be always bigger than the sum of nums1. Yeah. Now if it is less than 0 for nums1 and nums2, I need to change the 2 arrays. So it's going to be nums2 and nums1. Now I need to prepare a counter. So it's going to be a counter. So for nums1, I want to increase the value as much as I can, because the num1 is smaller. Yeah, so for example, this is a nums1. So the nums1 is smaller. I want to increase the value as much as I can. For example, I want to increase 1 to 6. Yeah. But I need to count how many values, but I want to count how many numbers of the increased value. So it's going to be x, it's going to be 6 minus x, so for x inside the nums1, and plus a counter in nums2, so it's going to be x minus 1, because for nums2, we're gonna decrease the value. Yeah. So for a value, we're gonna decrease it to 1. But what is the difference? So it's gonna be x minus 1 for x in nums 2. And this counter C gonna count all the differences like from 5 to 1 or from 1 to 5. Now we're gonna use the greedy idea to check how many operations do we need. Yeah, and we're gonna use this counter. So we're gonna check from the maximum value to the minimum value. So for I in range, we're gonna check the value of 5 first, and then to minus we're gonna check the value 5, like 5, 4, 3, 2, and 1. So it is a 5, 0, and minus 1 inside the range. So we're gonna check the value of 5 first, and let me prepare a result. It's gonna be the current operations we need. Yeah. So we need to have a check. So if this I is the value from the beginning, it is 5, and then we're gonna times the counter of this value, maybe 5. So 5 times say 5. In my example, maybe it is 15. But if it is more than the difference in this example 1, the difference is 11. If it is more than the let me use more than and equal, because if it is more than and equal, basically we need to stop the loop. It means that we've already found the answer. So it's going to be a result plus, as I explained earlier, it's going to be CL of the difference like 11 and divided by I is 5, so it's going to be 3. Yeah, but if this I times CI times the counter itself, so the total difference is less than the difference, so we're going to continue. And finally, definitely we can find an answer, so we're going to return it. Yeah. Now we want to increase the count, so the result gonna plus equal to CI, and we're gonna decrease the difference, so the difference is gonna be minus equal to I times CI. Yeah, and this is gonna be the final solution for this problem. So everything is about greedy. So here it is about greedy, and here it's also about greedy. Yeah, because we're gonna check from the maximum difference to the smallest difference, and this C is just a counter. We're gonna count how many differences for that values, and we just need to count how many of them. So we're gonna return this result plus the CL of D divided by I. I think only the difficult part maybe this is CL D divided by I. This means, for example, in this example 1, if the difference, for example, is 11, but the I is 5. Yeah. So how many operations do we need? So in this example, we need at least, we're gonna use a CL, so we're gonna at least need 3 operations instead of 2. Yeah, because for one operation, we can let 11 become 6, 11 minus 5, and 6 minus 5, let it become 1. And we still have a 1, so we need another operation. So we just need to turn a value, because the difference is 5. If the maximum difference is 5, definitely we can make the difference to 1. Yeah, if it is less than or equal to 5, it should be okay. So that is why we're going to use this kind of greedy idea to solve the problem. Now let me just run it to check. As you can see, it works. Now let me submit it. As you can see, it passed all testing cases, and it's pretty fast. Now let's analyze a little bit about the time complexity. Because of this counter, there are only 6 numbers, so we will not count it. Yeah, so for here, there are only 5 numbers, and we just need to check from here. So this is 05, it is okay. But from here, we calculated the sum of the values in nums 2 and nums 1, so the time complexity gonna be OM times OM plus N. M gonna be the length of nums 1, and N gonna be length of nums 2. So the time complexity gonna be linear, OM plus N. So this gonna be the final time complexity, because definitely we calculated the sum of nums 1 and sum of nums 2. So that's for it. Thank you for watching. See you next time.